Hello, this is Madam Lee, and for this lesson, we are going to learn how to prove that two triangles are similar. Okay, so this is quite the same as how we have proved congruent triangles. Okay, but this time around, we're talking about similar triangles. Okay, so this is a recap here on what are similar triangles. If two triangles are similar, okay, again, we can match its corresponding vertices. Okay, so the sequence is still important. And how do we determine it's similar is based on the equal angles. Okay, so if the corresponding angles are equal, we can say that okay, the shape is the same. Okay, the angle will determine the shape. Okay, so if all the angles are corresponding and equal, then it will determine that both triangles have the same shape. But for similar triangle, the difference is that instead of having equal length on corresponding sides, we are talking about ratio to be the same here. Okay, so meaning ratio give you the proportion. That means it is proportional. Okay, so the shape is still the same. It's just that it is not exactly the same because the sides, okay, are different, but they have the same ratio. Okay, so this is what similar triangle is about. Now, how do we prove similar triangle? Okay, so this is the focus at Sec 3 also. So there are three types of tests. Okay, congruent triangle we have 5 types. Similar triangle we have 3 types. Okay, so what are the 3 types? The first one is also SSS, side, 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 but it's not equal side we're talking about. It's not equal length we're talking about. This is for similar triangle. So we are talking about the sides having equal proportion. So let me do an example here. If I have a triangle here with the sides 2 cm, 3 cm, and 4 cm, and I have another triangle, okay, with the sides 4 cm, 8 cm, and 6 cm. So I can see that between the small to the big triangle, it is an enlargement by 2. Okay, because I times 2 is 4, I times 2 to 3 is 6, I times 2 to 4 is 8. So in this case, all the sides have equal proportion. So I can conclude that they are similar based on my SSS similarity test. Okay, we have to include the word similarity to differentiate it between the congruent SSS and the similarity SSS. Okay, so this is an example here. Okay, now the next test we're going to use is the AA test. Okay, notice that in this case we only need to have 2 A's. Okay, so why is that so? Let me give you another example here for AA. Now let's say if I have a equilateral triangle. Okay, if I have an equilateral triangle, what is the angle that we are having here? 60, 60, and another 60, right? Okay. If I have another equilateral triangle that is bigger, okay, what will be this angle? Also 60, isn't it? So because they are equilateral, they have the same shape, but they are proportionate on every other side. Okay, so I can say that they are similar based on AA similarity test. Okay, angle, angle, similarity test. Now for angle, angle, there is no need for a third angle because if I use 180 minus 60 minus 60, okay, I will still get the third angle to be the same, okay, even if I don't go and find it now. Okay, I only know there's 2 angles are the same. The third angle will also be the same because 180 minus these 2 angles will give you the third angle to be the same too. Okay, so I only need to state AA. Okay, there's no need for AA. There's no need for 3 A's. Okay, the last test for similar triangle is the SAS similarity test. Okay, so what it means is that if you are given that there is an angle, okay, that you know, and again, it has to be an included in-between angle, in between, okay, included angle. So if I know that the included angle is 30 degrees, okay, and I know that there is a corresponding side with a scale factor of k, and the other corresponding side also have a ratio of k, so it means that they satisfy that the sides have the same proportion, okay, the same ratio, and the included angle is the same. Therefore, I can also state that, conclude that, using the SAS similarity test, that these two triangles are similar. Okay, so these are the three tests. And now let's look at how we can apply the three tests to similar triangle questions. Okay, let's look at example 5. Example 5 is saying, for the following diagrams, name the pair of similar triangles with reasons stated for why they are similar. Okay, so let's look at part A. Now, the same as congruent triangle, proving congruent triangle, we have to first decide, okay, which is the test that we are going to use. Okay, so because the test that we've chosen to use, that is how we are going to display our reasons. Okay, and later we are going to conclude with the test that we use. So in this case, the info given are the sides and included angle, okay, and another side, right? Okay, this is all that is given. We have no idea what is ON. We have no idea what is QS, right? Okay, so this is to be an SAS test that we're going to use. So we start with the first side, okay? So based on the first S, okay, M correspond to P and Q correspond to N. So I'm going to state that MN over PQ, okay, has the ratio 1.5 over 4.5, which is 1/3, right? Okay, so I have this side here, and I have another side, MO over PS as 4 over 12, and the ratio is also 1/3, okay? Therefore, they are proportional, so I've covered my S, and then the included angle NMO is equal to the angle QPS. Okay, so this is given to be 102 degrees. Okay. Therefore, triangle NMO is similar to triangle QPS. Okay, notice that I cannot use the three strokes anymore because we're not talking about congruence. Okay, so do not use this anymore. Okay, so I say that these two triangles are similar because I have used the SAS similarity test. Okay, so this is how I present my proof. Okay, it is 3 evidence and 1 conclusion. Okay, now let's look at the next question. For the next question, I seem to have a variety of information. I have all my sides given. Okay, so it seems that I can use SSS. But I also have an angle that is given. So I also can use SAS, right? Okay, I have two options. Okay, I have two methods that I can use. It's either I use my SSS similarity, or I can use SAS, okay, the A being the right triangle, the right angle, right? Okay, so I can use either one. Okay, but since I have already used SAS just now, so now I'm going to use SSS to show you how to write this proof. Okay, so first I'm going to figure out where are the corresponding sides first. Okay, this is how I label. Okay, right angle, E and A, A and C. So let's start. Length AB over length ED. Okay, actually it is 6 over 10, which is 3 over 5 ratio. Right, okay, and I have BC over DC, which is 4.5 over 7.5. So if I use my calculator, it will also be 3 over 5 as the ratio. And last side, okay, I have my AC over EC, which is 9 over 15. Okay, so I have to calculate them on that 3 over 5 as well. Okay, so I count my side ratio. Therefore, triangle ABC is similar to triangle EDC. And the test that I've used is side similarity. Okay, so again, 3 evidence, 1 conclusion. Okay. Now, let's look at the last example for example 5. Again, in this shape, we see that there is no sides that are given, okay, no sides, so no ratio that I can use. So, but at one look, it seems like there is also no angle, isn't it? But they gave you this only clue. It is a pair of parallel lines. So now, what does parallel line tells us? Is there anything that we have used just now for parallel lines about angles? Now, in this case, there is no alternate angle, isn't it? But based on parallel lines, okay, we can tell certain information, okay, that this angle will be the same, right? Because they are corresponding angles of 2 parallel lines. So later we are going to target here. But if I'm working for to prove using an AA test, I will need a second angle, right? Okay. If I'm using AA, I will need a second angle. So I have the first angle, which is my corresponding angles. Okay. But what about the next A? So the next A, you have 2 options. Okay. Of course, there is another angle here. There is another angle here. Okay. There is another corresponding angles, right? But actually, there is another easier angle that, again, when you have triangles that overlap or triangles that stick onto each other, okay, there is this standard trick that you can also use, okay, which is about common angle. Just now we use common side, right? Okay, so now, okay, between this triangle, PQT, and the bigger triangle, right, they are overlapping, right? So there is a common angle that I can use. So in this case, I'm going to use these 2 angles, okay, to show you that common angle is a standard trick as well. Okay, so now let's start. So I have my PTQ equal to my angle PSR. Okay, so this is due to my corresponding angle. So I have to state the reason down. Corresponding angle because QT is parallel to RS. Okay, so you have to state about the parallel lines for the corresponding angle to be used. Okay, so that's my first A. The next A is my common angle. Angle QPT is equal to angle RPS, and the reason is common angle. Okay, so notice that I cannot always say given. Right? It's not actually directly given. It is deduced from my parallel line properties as well as overlapping triangles. So I can use these 2 reasons instead of just saying given. Okay, so therefore, triangle PQT is similar to triangle. Okay, so then you have to write the 2. Okay, so triangle PQT Okay, so I can say that triangle PQT is similar to triangle PRS, and this is my AA similarity. Okay. In fact, for AA, you don't have to write this word similarity because there is no AA under congruence. Right? There is no angle under congruence. So there is no need to include this word similarity. It's optional. Okay. Whereas if it's SSS, you have to use similarity because there is also SSS for congruence. Okay. So this one you have to write similarity, but this one you don't have to write similarity. Okay, now let's look at example 6. Again, we are supposed to identify two similar triangles, and we are supposed to calculate the values here. Now, for this example, there is no need. They didn't require, so there is no need to give, okay, the 3 evidence, 1 conclusion statement. Okay, because this is not proving. We are not proving here. They only want you to identify, okay, and then calculate numbers from the context that is given. Okay, so in this case, let's see what are the similar triangles first. Again, I have parallel lines. So parallel lines, I will be very sensitive to angles. Again, I have an alternate angle here. Okay, and I have a vertically opposite angle. There's another third A that we use. Okay, so anyway, this is just for us to figure out it is which vertex that is correspond to which. So in this case, because the Z is here, okay, I have a Z here, so I can say that Q will match S. Okay, the vertically opposite angle here is the same, so I can say that R match with R, and then P will match with T. Okay, so this is how I'm going to write it out. The two similar triangles will be QRP, okay, similar to, okay, I'm answering part 1, similar to triangle SRT. Okay, so I've answered part 1. Now, based on part 1, I can now find the unknown values for this triangle. So, okay, tip here, if the triangles are twisted, okay, and you don't know which side matches which, the best, okay, if you don't know which triangle matches which, the best way is to actually redraw this triangle. Okay, so based on part 1, if I have QRP and I have already claimed that it is, I have already, okay, show that it is similar to SRT, I'm going to redraw, okay, redraw these two triangles out because they are very twisted, so I can't really see which side matches which, right? So I'm going to redraw this, and now I'm going to fill up the length. So RQ, according to the diagram, is 6. So I'm going to write 6 here. QP is X, and then RP is 5. Okay, so if I were to redraw this, RS is my Y, ST is my 18 units, and RT is my 9 units. So if you look at these two triangles, it is much easier to compare which is the length that corresponds to which. And in this case, the side that both has both numbers that are corresponding is RP and RT, which is 5 and 9 units respectively. Okay, so based on this, I can find what is X, right? Okay, I can form a ratio. X over 18, okay, corresponds to the ratio 5 over 9. Okay, so I'm talking about scale factor here, huh? Okay, so based on this, I can cross multiply. So 9x equal to 90, and x is equal to 10 units. Okay, so I can do the same for comparing y. Okay, I can use a ratio y over 6 or 6 over y. Okay, it doesn't matter because later you're going to cross multiply. But if you decide to put y on top over 6, then we will have to use 9 on top over 5. Okay, so if I cross multiply, I will get 5y equal to 56. So y is equal to 10.8 units. Okay, so these are my two answers. Okay, so a really good tip is to redraw your diagram. Okay, so you won't be confused. If you don't redraw, there will be students who think that 6 is correspond to 9, but it's not. Okay, it's 5 that is correspond with 9. Okay, so please be careful. Okay, let's look at the next example. We are supposed to identify what are the similar triangles, and in this case, again, we have a parallel line to work with. Okay, we have some sides that are given. So based on the parallel lines, I can see that we have a common angle. Okay, because again, we have two overlapping triangles. And because they are parallel, we can have a corresponding angle, okay, based on parallel lines. So I would state that the two similar triangles are, okay, R is the common angle, okay, so I have A matched with P, corresponding angle Q matched with B, okay, so I can have RAB similar to triangle RPQ. Okay, so if you have a problem seeing, okay, let's redraw this. RAB 2, 4, 5. Okay, and I have a bigger similar triangle RPQ. Okay, and there's a parallel line here. Okay, so I have 6 here. I have RQ, which is x plus 5, okay, because I have x and 5. So overall it is x plus 5 here, so I write x plus 5. So overall here I will have y plus 4, right, okay. So this is how I can compare carefully later to find my x and y. Okay, so based on this, let me start with writing the sides that has both numbers 2 and 6. Okay, and let me solve for x first. So 2 over 6 is equal to 5 over x plus 5. Okay, because my drawing, I have already arranged the corresponding sides, okay, to be of the same position. So small over big, small over big. Okay, so again, if I cross multiply, 30 is equal to 2x plus 10. So if I solve this, x is going to be 10 units. Okay, so now I'm going to work on solving y. Again, I hinge on the sides that I know, 2 and 6, they're corresponding. So small over big, small over big. Okay, so if I cross multiply, 2y plus 8 is equal to 24. 6 times 4 is 24. So 2y is 16, y is 8. Okay, y is 8. So these are my two answers. Okay, so the tip here is to redraw. Now, of course, this is optional. Okay, this is optional, but it's a good tip. Okay, to follow. Okay, let's look at the last example for example 6. This question is a little tricky. Okay, but it is commonly tested. Why is it tricky? It's because now you have an angle that is at the top, and you have a given angle here. So there's A there, but there is no other A that is given. There is no parallel lines, so you cannot use your alternate angle. You cannot use your corresponding angles. So we have to figure out the next common trick, which is the common angle. So in this case, if I'm talking about this right angle triangle for the bigger triangle here, okay, as compared to this right angle, which is for this triangle at the side, the common angle we're talking about will be at R. Okay, so one possible pair of similar triangle is triangle AQR and triangle. Now, A match with which one, you're not very sure, right? Okay, so we leave it first. But Q is the place with right angle, so you match with P. And R is the common angle, so R will match with R. So this letter here will have to be Q. Okay, so this is our possible answer. Now, is there another possible answer that is on the other, this white color portion? Okay, is there another possible answer? Now, if we are to erase, okay, this one, we can see that if this is right angle, I also can have another right angle here, isn't it? Okay, because this is also right angle, so I also have a common angle. I also have a common angle at A that I can play with. So I can say that triangle AQP, the small one, the small red one, is similar to triangle A, the common angle. Okay, Q, which is okay, in this small triangle, Q is the one that is without the right angle. Huh? The right angle is at P. So A match with R, and the right angle P here will match with the right angle at Q. Okay, so this is another possible answer. You just need to state one. Okay. Now, for part 2, I'm now going to find this side, but because this is so twisted, okay, you better redraw this diagram. Okay, so I'm going to use one of the answers. Okay, let me use the first one, okay, to redraw so that I can put in my X and Y without seeing it being twisted. So AQR, okay, I will fill up the lengths later. A match with Q, Q match with P, and R match with R. So I've redrawn this properly so that they're matching. So AQ is given to be 1 units. PQ from the diagram is given to be 9. Okay, see that these two actually matches, but if you just look at this one, it's so difficult to tell. But if you were to draw it out, okay, it's easy to compare. AR, okay, which is X plus 12, we will state it on the redrawn diagram, and QR is our 15 units. So again, see, these two, if you were to look at the original diagram, there is no way to see carefully that they are actually corresponding, right? Okay, but if you redraw it, it is very clear. And QR on this side is 15, and PR is 12. Okay, so based on this, I can now match. Okay, this is the side that I have both numbers given. So I'm going to start off with 15 over 12 is going to be proportional or having the same ratio as X plus 12 over 15. Okay, big over small, big over small. So if I were to cross multiply, 225 equal to 12x plus 144. Okay, so if I solve this, x is equal to 6.75. Okay, so that's for x. The next one, again, I'm hinged on what I know. 15 over 12 is proportional or have the same ratio as, okay, big over small. So y is big, 9 is small. So if I do this, 12y is equal, okay, so y will be equal to 11.25 units. Okay, so these are my two answers. Okay, so for example 6, if there's no need to prove, okay, or give reasons, then you can just state. And then for finding values, please redraw, okay, so that it is easier to compare, especially when the diagram is very twisted, okay, overlap and twisting. Okay, let's look at the final example 7 for similar triangles. Now, in this question, actually, this is how people can measure the height of tall objects, okay, based on shadows that is cast by the sun, okay, and with an object, okay, that is known, that is in front. So, using similar triangles, how can I find the height of this tree here? The assumption here is that the pole is upright, okay, upright, and the tree is standing upright, so you have a corresponding angle here, okay, 90 degrees, and there is a common angle. So actually this is a similar triangle OPQ, and I have another similar triangle SOR. Okay, so based on this, I'm going to form my ratio. What I need is the height. So if I let the height be h over 4, okay, which is the corresponding sides, h over 4 is equal to, okay, big over small, right? So I have big 30 over 50. This is actually the only corresponding sides that I know. So I'm going to hinge on it to use its ratio to find the unknown here. Okay, so if I cross multiply, I'll get 120 equal to 15h. Therefore, h is equal to 8 meters. Okay, so this is an application on similar triangles.